which, yeah, I already talked to you about that. And there's a bunch of other things you have to do to be able to create this printed circuit board. You have to, biggest part is you have to make all these files that you have to send to the manufacturers, so the manufacturers have the information to be able to make the correct hole sizes, how long it's going to be, where the connections are routed so that everything is connected like it should be. And so I had to make all of those files, get all the dimensions of every single part that I was using on my board, which is right here. It doesn't look like you can see it very well, though. So that took probably the majority of the time. And then finally I got the Gerbers, which are the files that you send to the manufacturers, and I sent those off and got it back. Now the next thing I did is create the printed circuit assembly. Now that sounds completely different, but the only difference is the parts are soldered onto it. So that was the next part I had to do. I had to assemble all of the parts that I had chosen, or buy them, and then I had to solder them all on. And there's a few problems I had with that. There's two types of soldering, or two types of parts. It's surface mounted and through-hole mounted. Through-hole mounted is generally what most people use if they're doing it themselves, because surface mounted is using tiny parts, and it's what generally computers do, which is why it costs a lot more. So unfortunately, I was wanting to do all through-hole mounting parts for my design because I don't have that kind of money to do surface-mounted parts. But the step-up converter and the micro B port, those are only made in surface-mounted parts. So what I had to do is I had to go into my lab, if you could call it the lab, and I had to work under a microscope, essentially, and I had to solder this tiny part on. And that part is right there. So it took quite a bit of precision to do that. So finally, I get to all the testing. So I have my generator and my wheel connected. I have my eval kit and my own circuit board all hooked up. But now what I got to do is I got to test it all. I got to make sure it all works. I got to say the turbo wheel spins the generator, which it does. The water produces enough force and enough velocity to be able to spin the wheel, hence spinning the generator. And under those conditions, the generator will produce the required voltage, and the Zener diode makes sure it doesn't produce too much. And finally, circuit charges the lithium-ion battery, which is my temporary storage, and then the circuitry charges the cell phone. And so while that's all kind of boring, I have the more interesting representation of it, which is me actually demonstrating for you guys. I just went into the microphone. Me actually demonstrating for you guys that my design and my physical manifestation of this idea worked. So I'm using a drill to represent the water spinning the wheel. And what you'll be able to see is that once you get it at about 30 RPMs, which is about half the estimated maximum I said it could be, it will start charging the cell phone. Should pick it.
All right.
So that was the cool part of my project. And there's just a few more slides left. The final thing I did is I wanted to make it more practical because that's just the kind of guy I am. So I found a polycarbonate box that you'd be able to mount everything to, the circuitry, the generator, everything, and have the cell phone encased in it. So I found that, and I mounted everything. I had all of everything routed and all the wires set up, everything like that. So that was really the last part that I had to accomplish with my project. And what really makes this project great, I believe, is that it's what's called a proof of principle, is what I was trying to show, is that this is something that can be worked on and expanded upon in infinitely many ways. I mean, just a few of the things are having several batteries or several wheels. You could also integrate it into your house instead of having to deal with all the wires and the cell phones. You could just use an inverter and have it hooked up to your house system, and there you go. You know, you're saving money right there. Probably the coolest thing, though, that I really liked would be finding a way to recycle old cell phone batteries, which would be even more environmentally friendly. Instead of having to go buy a lithium-ion battery, instead use the ones that you already have available to you. And so those are just a few of the things. Every time I present this project to someone, whether it's just a bunch of people talking, it's always something I haven't thought about, that they say, oh, well, you could do this. You could use the storm drains, something Alabama Power could use. I'm like, yeah, that's pretty cool. And so I have to be funny and include a bunch of special things. So yeah, there all those are, and that's the end of my project. Any questions? Yes?
How long does the bee need to spin to
Oh.
get one full charge?
Sure. Through my estimations, it takes about an hour of simulated rainfall to be able to fully charge that lithium-ion battery, and that lithium-ion battery is equivalent and about the same size to the lithium-ion batteries that exist in our cell phones. So it would take about an hour. Alyssa.
Okay, so simulated rainfall, how many RPMs is that of your wheel?
The RPMs I needed a minimum to for this whole system to start working is about 30. So about half two revolutions every second.
You know how many inches of rainfall that's equivalent to?
No, I do not. Anshu had his hand up next, and then Connor.
How much would this wheel cost right now, the whole generator?
If you look at my whole system, really at this point, the cost is misleading, because what you'll find is that when you're in the initial stages of development of a product, buying them in small quantities costs much more. For instance, when I got my printed circuit boards, I bought 5 of them, and they were $70 a piece. If I bought 500 of them, they would cost $3 a piece. So the fact of mass producing them makes it enormously cheaper. My goal price that I had in mind would be about $40 for the whole system now. And then Connor?
How much would you sell one for?
$80. Gabriel's mom. It wouldn't be an attachment. It would be more of just something you could place under there, just right under the downspout.
Would it float in the air, or?
Can it float in the air?
Under a downspout?
Well, okay. So the downspout is at the very side of the gutter, and it has a little angle in where the water just gushes out, right? And so basically, you take my box, which is over there, and you just stick it under there. And that's really all you got to do for the setup. Miss Harrison.
What steps have you taken to protect your intellectual property here?
Yeah.
I've started looking at trying to patent this idea, but of course I have absolutely no idea how to do that. So
You can find those at Barnes and Noble.
I could.
Patent for dummies.
Patenting for dummies, there you go. But that definitely is something I've thought about. But what I made sure to do is I made sure to have proper documentation of all my steps so far. So if someone tried to come along and steal my idea, I could say, hey, I got this first. Don't try. Yeah. Any other questions?